Hey everybody, this is Mr. Beckstrom. Today I want to take a look at an example from section 9.2. And the question says convert to a rectangular equation and graph. And so for this one here, I want to do a couple of different things. I want to both convert this to the XY world and then put this in standard form. And I also want to graph this in both the polar form and the rectangular form. So we'll look how to do both of those in the calculator here. All right, so first let's go ahead and just kind of graph this just like it is. It's already solved for R, so that's a pretty easy thing to graph here. So if we go to our graphing calculator here, and we just have to go to mode, and we come down here and we change it from function, which is your rectangular system, and we're going to change it to polar. And I think we need to make sure that we go to radian. And then we're going to, when we go up to y equals, we're going to see instead of y1, y2, it's going to have r1, r2. So it's already solved for r. We can just put 3 and then cosine theta, just like it is there. And let's do a standard zoom here, 6. And we can see that it just looks like a circle here right outside. It looks like it's got a center right about 3/2, 0, and a radius of about 1.5 there, something like that. So that's what it looks like. So let's go ahead and put this into standard form. That's going to be the harder part, and then see about graphing it there. Okay, so in order to convert this, we need to use some equations that we know. So we know this. We know for the standard form of the circle, we know that x squared plus y squared is equal to r squared. We also know that x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. So we're going to use these kind of 3 equations in order to convert us from the polar side into the rectangular side. All right, so I have a cosine theta. So I'm going to see if, in order to get an r times cosine theta, I would need to multiply this side by an r. And if I multiplied the left side by an r, that would give me an r squared. Well, that's perfect, because then I can substitute that r squared with the x squared plus y squared, and then I'd be completely out of r's and thetas and completely into x's and y's. So that's what I'm going to do. I'm going to multiply both sides by r here, and that would give me r squared is equal to 3r times the cosine of theta. And then r squared is just x squared plus y squared. So that's just x squared plus y squared. And r cosine theta is just x. So this is just going to be equal to 3 times x. So this here is our equation. And then in order to put this in standard form of the circle so we can graph it, we just have to complete the square. So bring the x's over here, 3x. I'm going to leave a space there. Plus y squared is equal to 0. And in order to complete the square, I divide -3 by 2, which is 3/2, and then I square that 3/2, which is 9/4. So I'm going to add 9/4 to both sides in order to complete that square. So hopefully we remember how to do that. So we take the coefficient in front of the variable to the first power, we divide it by 2, and then we square it. So 3 divided by 2 is 3/2, and 3/2 squared is 9/4. So if I add 9/4 to both sides, then I can rewrite this as x minus 3/2 squared plus y squared is equal to, and I can write 9/4 as 3 halves squared, right? Yeah, so very cool. And that means that my radius is 3 halves, or 1.5, which is what I thought it was when I looked at that, right? I looked about 1.5 there. And my my center is positive 3 halves 0. And that looks right about right too. So that's my standard form there. And the last thing I want to do is I want to graph this using the rectangular coordinate system. So I'm going to take this form here and I'm going to solve for y. So going from here, I'm just going to subtract that x squared from both sides. So I'm going to get y squared is equal to negative x squared plus 3x plus 3x plus 3x. This is just subtracting the x squared from this equation up here. And then I can take the square root of both sides. So y is going to be equal to plus or minus, I'm going to get two equations here. Square root of negative x squared plus 3x. So this is y is equal to the positive square root of negative x squared plus 3x. Y is equal to negative x squared plus 3x. So when I go to graph this, if I go back to my mode and I go back to function, and if I go back to graph, notice that this is whatever I had in there from before. Let's clear that out. That should clear my graph out. Now, if I put in these two functions here, notice it's not nearly as elegant as my polar form equation, but hopefully it should work. So my first equation is going to be second square root of negative x squared plus 3x plus 3x. And my second one should be negative second square root of x squared plus 3x. Oh, I forgot the negative out front. So second insert, negative there, plus 3x, plus 3x. All right, and so this should be the top half and the bottom half of that same circle. And there it is right there. Notice that I get the same circle. They do half in blue and half in red. That denotes my y1 equation and my y2 equation. But I get the same thing. Now the reason that I can't do it all in one equation is because it only allows me to graph functions in the xy world. And a function has to pass the vertical line test, and a circle does not pass the vertical line test. So, but half circles do. So I can do two half circles in order to make the full circle. All right, so I hope this helps, and I hope that you see a couple of different ways that we can graph these. If you get comfortable with polar coordinates, it's a lot easier to graph them that way. But we can still usually do a workaround in the XY world as well. All right. Hope you have a great rest of your week. Thanks.